Welcome to our podcast episode, where we explore the topics of health and healthy aging. In today's episode, we draw our attention to a particularly relevant and often discussed topic: intermittent fasting. Is it really as beneficial as it is often made out to be, or are there aspects that make it seem less useful? Join us on this exciting journey as we shed light on the different facets of intermittent fasting. The practice of intermittent fasting, a method that has gained popularity in recent years, is a complex and nuanced topic that requires careful consideration. It is critical that you understand the intricacies and details of this approach because misunderstanding or misapplication can lead to significant health problems, including an increased risk of diabetes. Intermittent fasting is not just one method, but there are different forms, each with their own characteristics and benefits. The most popular form is time-restricted eating, where you only eat within a certain window of time each day, usually within 8 hours, and fast for the remaining 16 hours. Other forms include alternating day fasting and fasting with only one meal per day. The enthusiasm for intermittent fasting arose from studies in rodents that showed that this form of time-restricted eating reduced body weight, improved blood sugar control, and lowered insulin levels. Interestingly, these benefits occurred even though dietary intake was the same as the control group. So both groups of mice ate the same amount of calories, but the time-restricted group seemed to benefit from all of these additional benefits. This led to an explosion in popularity of intermittent fasting, where many people sought a certain level of longevity, even if they didn't need to lose weight. Scientists began to advocate intermittent fasting as a strategy to extend life expectancy. The suspected mechanism for these possible benefits was a process called autophagy, the cell cleansing process. As we age, we accumulate old damaged components in our cells, and autophagy is the process by which we remove these old components so we can build new ones. And autophagy is strongly activated by starvation. But we're not mice, we're human. And human clinical research has revealed some of the secrets of intermittent fasting. A 2020 meta-analysis that summarized all relevant clinical trials concluded that time-restricted meal consumption had better effects on weight loss and blood sugar reduction compared to time-restricted meal consumption approaches. This shows that intermittent fasting, when used correctly, can actually have health benefits. But delving deeper into the matter reveals a complex and multi-layered reality that requires careful investigation. Let's take a closer look at one particular investigation. In this study, a group of participants were subjected to a diet known as time-restricted eating. Compared to the control group, who did not restrict their calorie intake, the test group consumed fewer calories overall. Analysis of research results suggests that this form of nutrition can effectively promote weight loss. The most likely reason for this is reduced calorie intake. This makes intuitive sense because if you consciously choose not to eat during certain periods of the day, you will tend to consume fewer calories overall. But what benefits does intermittent fasting offer beyond just calorie restriction? A Cochrane review published in 2021 suggests that intermittent fasting is no more effective for weight loss compared to other energy restriction diets. The analysis also found that intermittent fasting is no more effective at lowering blood sugar levels than other energy-restricted diets. For example, consider a 2019 randomized controlled trial that tried to ensure that both groups consumed the same amount of calories, but one group fasted every other day. The study concluded that second-day fasting may result in a greater reduction in fasting insulin than calorie restriction. This sounds promising at first, but a closer look reveals a different picture. During this study, both the second-day fasting and calorie restriction groups reduced their net calorie intake by 25% per day. The calorie restriction group consumed 1,761 calories per day, while the group fasted on the second day. The groups ate 1,175 calories on their fasting day and 1,763 on their all-you-can-eat day. Overall, the fasting group still consumed fewer calories on the second day compared to the calorie restriction group. So if one group eats fewer calories compared to others, they see benefits. What about potential hunger benefits? Some people who practice intermittent fasting report that their overall feeling of hunger decreases. And if that applies to you, that's great. But in clinical trials, most people generally have difficulty maintaining fasting. Compliance is not optimal. There will always be exceptions to the rule, but in general, fasting will not reduce your overall hunger. And what about the benefits for fatty liver disease? Here, the research becomes even more complex and requires an even deeper investigation. But one thing is clear. A large 2023 randomized controlled trial showed that time-restricted food intake provided no additional benefits in reducing body fat or liver fat compared to daily calorie restriction. Further meta-analyses that summarized all relevant clinical studies came to similar conclusions. Intermittent fasting was not associated with greater or less weight loss than non-intermittent fasting diets. From Professor Matt Kaberle's review, modern intermittent fasting protocols are largely a rebranding of classic calorie restriction methods. Here lies the dark secret of intermittent fasting. People who use intermittent fasting for weight loss and diabetes management gain these benefits from calorie restriction alone. From the human research we have, there is nothing magical about intermittent fasting. For otherwise healthy people who don't need to lose weight or manage their diabetes, there doesn't appear to be any benefit to practicing intermittent fasting. However, there are two scary problems with intermittent fasting that I'll address in a moment, and both can be solved. First, why don't humans benefit from intermittent fasting beyond calorie restriction like mice? Well, it's important to remember that a mouse hour is not, broadly speaking, the same as a human hour. If a mouse fasts for 16 hours, that is roughly equivalent to a human fasting for about 4 to 5 days. And the human liver has energy reserves that last about 48 hours. So it is highly unlikely that autophagy will be activated in a meaningful way if you fast between 16 and 24 hours. Prolonged fasting can have different effects, but then you have to worry about losing muscle mass. This brings me to the first of two problems with intermittent fasting: protein intake and muscle mass. A 2020 study published in the British Medical Journal found that higher protein intake is associated with lower overall mortality rates. And ideally, we want to achieve a protein intake of 1.6 grams per kilograms of lean body weight per day. But when you're fasting, it can be incredibly difficult to achieve these protein goals. This is an important aspect to consider when considering intermittent fasting. Intermittent fasting, although touted as an effective method for weight loss and improving overall health, may paradoxically represent a suboptimal approach to skeletal muscle remodeling. This is a complex topic that requires careful study, and there has been a recent major update in protein research that provides new insights. Conventional wisdom long held that spreading protein intake evenly across several meals throughout the day was ideal for muscle protein synthesis. However, this assumption was upended by a groundbreaking study published in 2024. Researchers found that consuming a large bolus dose of protein in a single meal may be just as anabolic as consuming the same amount of protein divided into multiple smaller doses. This novel protein timing data may help explain why time-restricted eating patterns like intermittent fasting do not appear to impair muscle mass maintenance, despite prolonged periods without food intake. When it comes to preserving muscle, the total daily protein intake seems to be the critical factor rather than the frequency of protein feedings. For those utilizing intermittent fasting for calorie restriction, weight loss, or metabolic health, prioritizing adequate protein intake becomes paramount. If hitting protein targets from whole foods proves difficult within the feeding window, supplementing with a nutrient-dense protein shake can be an effective strategy to ensure protein needs are met. Another fasting approach garnering interest is prolonged fasting, extended periods of complete calorie abstinence lasting multiple days or even weeks. However, the potential for lean muscle loss is one of the most frequently voiced concerns. It is a valid apprehension, as the body does catabolize muscle tissue as an energy reserve during prolonged nutrient deprivation. Unfortunately, comprehensive long-term human data on prolonged fasting and its impact on body composition is still lacking. To date, there are no conclusive studies demonstrating whether the purported benefits of prolonged fasts outweigh the risks of lean mass catabolism. The science is still in its nascent stages when it comes to fully elucidating the effects and potential applications of prolonged fasting protocols. A potential strategy to mitigate muscle loss during fasting could involve incorporating resistance exercise into the fasting period. This could theoretically help decrease muscle loss by stimulating the muscles and prompting the body to draw more energy from fat reserves rather than muscle tissue. However, the research on this topic is not yet conclusive. It remains unclear how effective this method truly is and whether it's suitable for everyone. Further research is needed to answer these questions. One issue that can be addressed is meal timing. Most individuals who practice time-restricted eating skip breakfast and consume a large meal at the end of the day. This approach is not ideal. Numerous studies have shown that consuming a large meal late in the day can worsen blood sugar levels and impair insulin response. These findings underscore the importance of proper meal timing and the need to adjust our eating habits accordingly. The importance of breakfast is widely recognized, and recent research on intermittent fasting is exploring the concept of early time-restricted eating. The objective is to consume the majority of your daily caloric intake in the morning, followed by a period of fasting during the evening. This approach aligns with our body's natural circadian rhythm, potentially optimizing metabolic health. To summarize, intermittent fasting can be an extremely effective method for some individuals to lose weight and manage their diabetes. If you're one of these people, that's great. However, it's important to remember that intermittent fasting likely works primarily through calorie restriction. The role of autophagy in this process is still unclear, as peak levels are only reached after several days of fasting. This aspect requires further investigation. In humans, there's no evidence yet that anything beyond calorie restriction is occurring. It's crucial to remember that everybody is unique and responds differently to dietary and lifestyle changes. There are two significant yet solvable challenges associated with intermittent fasting. The first relates to protein intake. Many individuals who practice intermittent fasting do not consume sufficient protein. By being mindful of this, you can prioritize your protein consumption and aim to achieve the recommended intake of 1.6 grams of protein per kilogram of body weight each day. The second challenge involves meal timing. Strive to consume the majority of your calories in the morning rather than the evening. To significantly enhance their health, most individuals should aim to consume a light dinner early, brush their teeth immediately afterward, and then abstain from eating late at night. As a general guideline, consume breakfast like a king, lunch like a prince, and dinner like a pauper. Indeed, as VLDLs, very low-density lipoproteins, decrease in size, components can detach, which are then absorbed by small HDL, high-density lipoprotein particles, and ultimately become large HDL. In simple terms, ApoB lipoproteins like our VLDLs start large and then become small, while HDLs start small and become large. This process elucidates the phenomenon of lean mass hyperresponders, as increased secretion and turnover of VLDL into LDL, low-density lipoprotein, can lead to a higher LDL concentration. More triglycerides are mobilized into the bloodstream. However, the turnover of these ApoB lipoproteins releases more components that can be absorbed by HDL, potentially explaining the higher HDL cholesterol levels. Metabolic health results in lower triglyceride levels, which may explain the lower triglycerides and why this triad phenomenon is so prevalent across various populations, ages, and ethnicities. But why are leaner and metabolically healthier individuals more likely to exhibit this lean mass hyperresponder profile? To answer this, let's discuss large fat cells and traffic genes. Imagine two highways, Highway A and Highway B. Now imagine you're a truck driver. I'm telling you, trucks are dangerous. There are numerous studies demonstrating the dangers of trucks. However, upon examining these studies, you realize they only ever occur on highways like Highway B. Could this be a problem for science? It's possible. With this in mind, let's discuss the main exit. The study titled Fat Cell Size investigates the measurement methods, pathophysiological origins, and relationships between metabolic dysregulations. Stripping away the technical jargon, it's about adipocytes, our fat cells. As they enlarge and fill up, they become dysfunctional. And if they become dysfunctional, they can even die. You often find an increasing number of macrophages, immune cells that take care of them. This is strongly associated with what they term dysmetabolism or lipid dysmetabolism, which I would simply call dysfunctional lipid metabolism and its association with cardiovascular disease. But don't worry, we'll delve into that in more detail shortly. From this study, particularly from Figure 6, it's evident that visceral fat cells, the visceral fat primarily around the midsection of the body, but a specific type of adipose fat, where the population of these adipocytes is larger, tend to be associated with higher fasting insulin, HOMA-IR, and fasting blood glucose. This probably doesn't surprise you, but equally, they tend to be associated with lower and lower HDL cholesterol levels and higher triglycerides, as well as rising LDL cholesterol levels. So it makes sense why all of these values are in a collinear order, why it's important to look at them all separately in this way when looking at them together, why they belong together. Now, let's circle back. I'd like to reiterate that the benefits of intermittent fasting are likely attributed to calorie restriction rather than a direct, potent stimulation of autophagy. This shouldn't be perceived negatively. In fact, among aging researchers who seldom concur, calorie restriction is the most extensively studied method for prolonging lifespan and health span across all animal models. If we apply this method to humans and seamlessly integrate it into our daily lives as a permanent lifestyle, coupled with sufficient protein intake and resistance exercises, it's even more beneficial. It enables us to enjoy the advantages of calorie restriction while preserving our muscle mass and enhancing our overall health. It's a win-win scenario that boosts both longevity and quality of life. Therefore, it's not solely about fasting, but also about how you fast and the other health-promoting behaviors you incorporate into your lifestyle. But we don't have all the answers either. Our experience suggests that the Mediterranean diet often appears to be an excellent choice. It's backed by numerous studies as particularly health-promoting and is primarily based on plant foods and lean protein. This dietary approach could also be beneficial for you. However, it's important to weigh individually what works for one person may not always work for another. Each person is unique and responds differently to dietary and lifestyle changes. As we approach the end of this episode, we deeply appreciate your interest and the time you've dedicated to us. We sincerely hope we've been able to offer new perspectives and valuable insights. Until we meet again in the next episode, we wish you the best of health. In the meantime, stay curious.